Hey there, Y10s. In this video, we are now going to look at working on exercise 8E, which is called two-step experiments using tables. I like to use tree diagrams and sometimes I use tables as well. But in this example, or these exercise, it's to get you to solve problems where there are two steps to things. And what does it mean by two steps? In this particular example, let's have a look at this one. It says, for example, if you had a fair six-sided die, okay, and then you rolled it twice. Now, usually you roll it once and you say, what's the chances of getting, say, a 3, right? Then you would say that's 1 out of 6. So that was pretty easy. But then what if I said, what's the chance of you getting a 3 and then chances of getting a 6 afterwards, right? That changes the probability a bit because you're taking 2 steps, or technically 2 rolls. So how do we start to solve this type of problems for two-step experiments? Well, a table can help illustrate all the possible outcomes. So here in this particular example, if you roll the dice twice, you get 6 options here. On the first roll, let's say this was the first roll. On the first roll, you could have got a 1, 2, 3, 4, 5, or 6, right? So those are the possibilities. And then on your second roll, you could have got, again, 1, 2, 3, 4, 5, 6. So what we do is we illustrate this in a table, and we say, well, you could have got 1 on the first go, then 1 on the second go. You could have got 2 on the first go, and then 1 on the second go. You could have got 3 on the first go, 1 on the second go, 4 on the first go, 1 on the second, and you get the pattern, right? So these are your possibilities, but if I illustrate it all out, you see, first roll, if you got a 1, well, then you got a 1, 1, 1, 1, 1, and then you would have got 2, 3, 4, 5, 6 on your second roll, right? And you fill out the table, and hopefully you start to see, well, you can tell what's the total possible outcomes, or what's your sample space. Well, there's 6 by 6. 6 times 6, there's 36 options in total here. So we can fill it all out, and I'm just going to fill it out so that you've got all the answers here. So 2, 2, 2. That's 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. This would have been 3, 2, 3, 3, 3, 4, 3, 5, and then 3, 6. This would have been 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. We're almost there. 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And then you could have got 6 with a 2, 6 with a 3, 6 with a 4, 6 with a 5, and then 6 with a 6. So clearly, there's a total of 36 possibilities that you could have got. When you roll a dice twice, those are the possibilities, right? Now that you got the table, it's very visual. You know it's out of 36. Find the probability of obtaining the outcome 6 on the first roll and then 4 on the second. So in that case, probability of getting a 6 and then a 4. Okay, so I'm using intersection because it's getting 6 and 4. So the word and is intersection. So 6 and 4, well, we know it's a total out of 36. And how many 6 and 4s are there? Well, there's only one possibility when you get 6 on the first go and then 4 on the second. Okay, now the problem here is they haven't specified specifically, is it 6 on the first and then 4 on the second, or is it just saying what's the chance of getting a 6 and a 4? Well, chance of getting a 6 and a 4, you could have got this one and that one. So it really depends on how specific they say in the language. That's where you got to be careful. In this case, they never said 6 on the first and then 4 on the second. So I would actually stick with the idea that you get a 6 and you get a 4. Well, then there's 2 possibilities that you could got there. You could have got 4 on the first and then 6 on the second, or you could have got 6 on the first and 4 on the second. So hence you have to keep it in account of it, unless the language changes. So unless they said 6 on the first and then 4 on the second specifically, right? So here I would then say it's 2 out of 36, so that's 1 out of 18. Okay, but it's a bit tricky because they wrote 6, 4 in that specific way. I mean, it could have been 1 out of 36. It's one or either. So it depends on the language there. But often, if they wanted one outcome, they would have said getting a 6 on the first go, and then 4 on the second. Something like that. Okay? All right, next one, B. What's the chance of getting 3, 2, or 2, 3? Oh, actually, so it sounds like they're very specific then. If they're putting in brackets, it looks like it's on the first go you get a 2, and on the second go you get a 3, and then this one on the first go you get a 3, and then you get a 2 on the second go. So it looks like it's very specific, so my bad. It should have been actually 1 out of 36. There you go. Okay, so in this case here, they're saying, well, what's the chances of getting 3 first, then 2 on the second, or getting a 2 first and then a 3 on a second? Well, in this case, there's really only 2 options here. The chances of getting a 3, 2, and then 2, 3, well, there's only, 2, 3 is here, and 3, 2 is there. There's only 2 out of 36 options there. So it's 2 options out of 36, and that gives me 1 on 18. Okay. C, probability where they sum of at least 9. Ooh, okay. So if they all add up to at least 9, so 9 and above. So if you sum them together, let's add them together now. So this would have gave me 2, 3, 4 if you add these digits together. So 2, 3, 4, 5, 6. This would have been 3, 4, 5, 6, 7, 8. This would have been 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Now the reason why I do this is because then it's easy for you to see. So they say summing at least 9. Well, to add up at least 9, how many options do you have? You've got, this is 9. You see that diagonal? And then everything over here is more than 9. So that means how many possibilities do you have? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are actually 10 options. 10 options. There's 10 out of your 36 possibilities. So that works out to be what, 5 on 18? All right, so we've got that one down. Let's go next one. Sum less than 4. So now that I've done the table, it's much easier to see. Less than 4, well, this is less than 4. 3 is less than 4. Some of this is less than 4, and some of this is less than 4. So really, there's only 3 options there out of your 36. So that would be 3 out of 36. Gives you a nice 1 out of 12. All right, and then lastly over here, find the probability of a sum of 3. So you need a sum to give you 3, given that the sum is at most 4. Ooh, so this one's tricky. So this is combining conditional probability. What's the chances of getting sum 3? Okay, so it has to add up to 3. Given that, so this is where it changes, that the sum is at most 4. So it's at least equal to 4. So at least equal to 4. So it could be 4, 5, 6, 7, 8, 9, 10. So that changes things, because how many numbers, it's not out of 36 anymore, how many of all of these add up to at least 4? At least 4. So yeah, let's have a look where the 4 is. I'm just going to rub this one out. So we know that summing 3 is clearly these 3. These 3 guys, so these 2 guys will add up to 3. But what's the chances of that if it's at least 4? They have to add up to at least 4. Well, let's have a look at the probability here. If you're going to get at least 4, this is 4, 4, 4. And at least means that it could be 5. They could add up to 5. So really, it could be all of this, right? So how many options are there if I circled all of those? Well, that's 30. That's total's 36. There's only 3 of them that don't equal to 4. So there must be, out of 33 options, out of 33, because there's 1, 2, 3 that don't add up to 4, at least 4, right? So if there's 36 in total, well, minus 3 gives you 33. Right? So now you know that, okay, well, it's out of 33. How many of those will add up to 3. But isn't it funny if you think about it? Out of this group here, how many of those will sum up to 3? None. Because you literally just said you need them to at least add up to 4, but then you say, what's the sum? What's the chance of picking one that's going to add to 3? Well, that's not going to happen because you're saying at least 4. They have to at least add 4 up to 4 minimum. But then you're saying, well, what's the chance of getting one that's going to be adding up to 3? Well, you set a benchmark. You said everyone has to get 90%. What's the chances of picking someone in that group that's going to get 30%? Doesn't make sense. It's 0. There's 0 chances of picking someone who is going to be in the group where they got at least 4 if they only added up to 3. True? So it's actually 0%. So it's a bit of a trick question there, but I can see why a lot of students will find that tricky. So have a pause, have a think of what I was just saying there. You got to think of it logically, and I think that's where the fun of the last question was getting you to do there. Okay, so that's example 1, and what you're seeing there is I'm using a two-way table, also a table there to help you visualize what's actually happening in our problem to answer the questions. Yeah. Now let's do example 2. You can use a table. I personally normally like to use tree diagrams unless it was like the scenario before where you have too many options and making a tree diagram makes it more complicated. When the problems are less complicated, less branches, less options, then I like using a tree diagram. Okay, so in this example, let's have a look. You got 2 cars are chosen. So you're choosing 2 cars from a group of 4 options without replacement. So once you pick one, you can't pick the same color again. So of the 4 cars, 2 are red, 1 is blue, and 1 is white. So you can choose on your first go. You've got a red to choose from, a blue, and then a white. After you pick the first go, so let's say this was the first go, then you pick another one. So your next option could be, again, you picked a red. You could pick a red. You could pick a red. You could pick a blue. You can pick a white. But here you got to be careful because it says without replacement there. Okay, so if they say without replacement, let's have a think. I could have picked a red on the first go, right? But there's no way for me to pick this same red again on the second go because I already picked it. True? So this one cannot exist. And the same thing goes for all of this diagonal if you figure it out. If I picked this particular red on the first go, there's no way I could have picked it on the second go because it's without replacement. So it's gone. I've already picked it. So there's no way I can have picked this one. And the same thing with this one. If I picked a blue on the first go, I couldn't have picked blue again for the second go because I've already picked it. So these are all going to be cancelled out. And that means here you go. You can have possibility of picking the second red on the first go. Okay, the second red on the first go. And then the first red on the second go. That might have been confusing with the double R's there. Okay. Maybe if you labeled them, that might help you sort of visualize what I'm saying. So if you call this R1, R2, and this is R1, R2, it might help you to see that if you picked R2 first, then it's okay to pick R1. That's what I'm trying to say. Okay. And then you could have picked blue on the first go and then R1 on the second. You could have picked white on the first go and R1 on the second. You could have picked R1 first and then R2 second. You could have picked blue and then R2, white and then R2. You could have picked R1. This is obviously R1, blue, white, and you get the gist from here. So it's R2 on the first, and then you could have got a blue. You could R2 first, and then got a white. You could have got blue and then white, and you could have got white and then blue. Okay? So that's using a table there for you to see. Or if you use the tree diagram, it would also work in the same idea. This might help you with the reds to help you visualize it. So I could have got red on the first go, red or this other red, blue, or white. True? But then on my second go here, if I've chosen the first red, so this is R1, then I can only get the other red. There's only the one other red left over. and then you could have got a blue or you could have got a white, right? But had I chosen this red, R2, then there's only the other red left over, so R1, blue, or white. And then same thing, if I chose a blue, well then I've got both R1, R2 optional, and then white. And then obviously with this one, you could have got white with R1, R2, but then you got blue as your next option to choose. Okay, so if you list it all out, you can see you would have got R1, R2 for this option. This option would have been R1 blue. This one would have been R1 white. And you can see that it's R1 on the first go. And that essentially is the same thing as what I was doing over here. R1, R2, R1B, R1W. So it's up to you how you want to draw it. This could be the table. It might have been easier to do it this way, or you prefer the other table. I prefer the tree diagram. It's up to you. Okay, so here if you continued on, you would have seen it's R2, then R1, R2, and then blue, R2, and then white, and so forth. Okay? All right. Now that you can see the two possibilities or two options, let's answer the questions. A, find the probability of obtaining a red car first, then a white car. Well, if you're getting a red and then a white, well, let's look for RWs here. So if you're looking for RWs, you can get first one, the first one is a white and then red on the second. Well, you could have picked, where's this one? You could have picked white and then R2, but then that means you could have done the same over here. R1, then W, or R2. So there's actually 4 possibilities there when you could have got a red. Oh, actually, no, they said red first. So they want a red car first and then a white car. Sorry, my bad. So if they want a red car first, then this is the first option. So you could have got R1 white or R2 white. There's only 2 options there that you could have got red first. So 2, probability of getting red, then white, is equal to 2 out of, now what's the total? Now hopefully you can either count it from here, you can count it from here, or logically over here, you know that there are 4 options, and then for every 4 in the next go, you got only 3 options for the second go. So therefore 3 by 4 gives you a total of 12. Okay, or you can think of it as this is one group of 3, 2 groups of 3, the next one will give you another 3, the other one gives you another 3, so 3 times 4 is 12. That's another way of thinking about it as well. Okay, or you can count this. It's up to you. Yeah, so there should be a total of 12 options, and your probability is 1 out of 6. Okay, next one, selecting 2 red cars. Well, probability of getting red and red, right? Red and red. Well, let's have a look how many double R's there are. So you can already see there are red, red. That's 1, 2. What's other red again? There should be another red somewhere. No, there's only those 2. Those are the only ones that you get to because you can't repeat picking the same one. So it's actually 2 out of your 12 options. And again, it's 1, 6. Okay. Moving on to the next one, selecting 1 red car and then 1 blue car. So this one doesn't matter which order, whether you pick blue first or red first. It actually doesn't matter. It's just saying chances of getting a red and a blue. So if the order doesn't matter, well, let's how many red blues can we get? Well, red blues, I can get red blue here, red blue here. I can get red blue here. I can get red blue here. And that's all. That's the only one. So that's 4 out of your 12. That's 4 options out of the 12, which gives you 1/3. Okay. And then your last one, selecting 2 red cars given. Now that's conditional probability. So what's the probability of selecting 2 reds? Okay. Given that at least one of them is a red car. So you already knew that you already got a red. So because it says at least one of them is red, it means that you could have 1 red or both reds. Okay, so this is very interesting. This is at least 1 red. Now, if you're using logic, the logic is how many cars is at least red. Well, how many cars are there that is at least red? Well, think about it. This is red, this is red. That's the only times you're going to get red. But then you also got red over here, and you got red over here. So that's a lot of cars if you really think about it. But you can look at the tables to count it, or you can look at the tree diagrams. To me, that's already 6. That's 6 there, plus 2, plus 2. So that's 10 cars that I can see that will have a red. But you can also use this table to help you visualize if it helps you better with the table. So here you can say, this is a red, at least 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 a red. So you can see there, that's 10 options there. If you count that, that should be 10. Okay, so that's at least a red. So there are 10 cars that are at least a red. Now, out of those 10 cars, okay, so I'm going to zoom out and come back. So out of those 10 cars, okay, it's at least a red. So out of those 10 cars, what's the chance of getting a red and a red? Well, hopefully you can see out of those 10, let me just circle it again. So out of this group, so I think that was the only one that has all the reds, and then these ones have the reds. So those are your 5. Out of the group that I've just circled, how many is red and red? And hopefully you can see red and red is this one and this one. There's no other ones that are going to be red and red, right? You either get the first one R1 and then R2, or R2 then R1. So there's 2 out of your 10. And therefore the answer is 1/5. Okay, so that's why conditional probability to me is the hardest one to get. For a lot of students, it could be a mixture of everything, like with conditional probability to tree diagrams and all that. But that's how you work through it. If you follow me, you can see that it's quite logical. It's just that you have to problem solve as you do it, and these diagrams help you problem solve. So learn one of the skills, either a tree diagram or a table. In this exercise is about the table. Okay.